Okay, so basically I'll discuss all the few questions from week 7 to 9. So yeah, so let me start with first. Let me start with sequence. Okay, so if you have any doubt in between, please stop me and ask your doubt. Okay. So as you know, basically sequence is nothing but it's basically a map from the set of all natural number. So since we are basically dealing with real sequence, so sequence is nothing but it's a map from the set of all natural number to R. Okay, so basically you have A1, A2, A3, A4, and so on. And what we want to find here, we want to find where this sequence approaches when n approaches to, so when n is actually going towards infinity. Okay, so we want to find the limit point of the sequence. So when we have a point A, such that this term of the sequence approaches to A, where when n is going towards infinity, at that time we say that this point A as a limit point of the sequence A. Okay, so when we don't have such point A, then in that case we call this sequence as a divergent sequence. Okay. So let me start with this question. So suppose we have the sequence an. So the nth term of the sequence is basically 2n square root of 2n plus 1 minus square root of 2n. So what we need to do here, we need to find the limit point of this sequence, right? So can one of you tell me how I can get the limit point of this sequence? Hello, am I audible?
Yes, sir.
Yeah, any idea how I should solve this question? So have you studied all these things, or like?
Hello, sir.
Yeah.
Sir, is
Uh,
there is syllabus in the diploma program?
huh? So
Isn't there syllabus?
yeah. So the calculus is there, right?
Sir, it's for diploma for data science, I think.
So this calculus is not there in your syllabus.
Yes, sir.
So
Only for
what
data.
is okay? So then can you tell me for what is the aim of this session? Then probably this is for okay. Just
Some
a
of
minute.
us were from data science also.
Okay, some of you are from data science, right?
Yes.
Yeah. So
Yes.
so then this is relevant for you, right?
Correct.
Yeah. Okay.
Correct.
Yeah. Okay. So basically, yeah. So so in this session, basically, I'm going to discuss all the things related to calculus. Okay. Okay. So if certainly, yeah, if this part this is not in your syllabus, then I don't see any point of joining the session. Yeah. So okay, so the thing is we want to find the limit of the sequence. So as you can see, the sequence is basically so what is an? An is 2n plus 1 square root of 2n plus 1 and also minus square root of 2n, right? So this is the sequence. So as you can see, we cannot so by just simply looking at this sequence, we can't get the limit of the sequence, right? So what we need to do, we need to actually rationalize this sequence. So first we have to rationalize this sequence. So for that, what we need to do, we need to multiply something in the denominator, as well as we need to multiply something in the numerator. Okay, so first let me multiply. So basically what I will do now, I'll multiply 2n plus 1 square root of 2n plus 1 plus square root of 2. Okay, so I multiplied this in the numerator, then I will multiply the same thing in the denominator, right? So in the end, basically I'm multiplying 1. Okay, so I'm actually not changing the sequence. So I have basically the same sequence. So once I multiply this thing, then what I will get? So in the numerator, what I will get now? I will get 2n plus 1 minus 2n divided by 2n plus 1 square root of 2n plus 1 plus square root of 2n, right? So in the end, what I am getting? 1 by square root of 2n plus 1 plus square root of 2n, right? So you can see that if n tends to infinity, then it's clear that this thing 2n plus 1 plus square root of 2n will go towards plus infinity, right? So if n tends to infinity, then this thing will go towards plus infinity. So what we are basically taking here, we are taking the reciprocal of this thing, right? We are taking the reciprocal of this thing. That means this thing will go towards 0, right? So finally, what we are getting? We are getting 0 as a limit of this sequence. 0 is the limit of this sequence. So is it clear now? Any doubt from this question?
So Vashish, I wanted to know how do you is where in the question is it mentioned that the limit is tending to 0?
No, we need to find the limit.
Okay, but limit when it tends to what value?
So by definition, so when actually you are finding the limit of a sequence, so at that time you have to take this n towards infinity, right? That is
Sure.
that is how you find the limit of a sequence.
Okay.
So
Alright.
that is what we are doing here. We are so when so basically what we are doing here, when n is going towards this infinity, then basically we are showing that this sequence is going towards 0, right?
Okay.
So that
Got it.
basically means 0 is the limit of the sequence.
Okay. Thank you.
Yeah. Okay, is there
Uh,
any? Huh.
Yeah, a simple question, maybe dumb. When we substitute n as infinity, the first term, an becomes 2 into infinity plus 1 minus 2 into infinity, which is infinity minus infinity. Can't we just say it will be 0? Is
No,
that
no, actually, so that is the problem. So you can't say so the thing is infinity is not a real number, right? So
right? Right.
infinity is not a number. Okay.
Hmm.
So this addition and multiplication uh, and subtraction, that doesn't make sense for infinity. When you have some real number, then from there itself you can say that this infinity, sorry, some natural number minus natural number is 0. Okay, but
Okay.
when you have infinity minus infinity, from there actually you can't conclude anything. Okay, so
Okay.
but
May
but
may I s- may I, may I say, like, if the question was different, like an is root of 2n plus 1
hmm,
plus root 2n. In that case,
in that case actually you can say, because you don't
oh,
have this minus symbol. So if something is large and another thing is also large, and if you add these two large numbers, then actually you will get a large number. Okay,
understood.
but
Understood.
when you are
Understood.
subtracting things, then actually you can't say. Okay, so that
Okay.
is the problem here. You have a minus sign. So if you have some positive sign, then from there itself you can say that the sequence an will diverge towards plus infinity. Okay.
Understood. Understood. Thank you.
Yeah. Okay. Yeah. So okay. So the next question is so you have this sequence. So this is slightly different sequence. So here the sequence is defined. So you have a single expression for this sequence, right? So once you substitute n equal to 1, then so if n equal to 1, then you can substitute in this expression. So here, as you can see, you have two expression for this sequence. So one, basically one if n is odd, okay, and another one if n is even. So for example, a1 is what? A1 is 10 plus 1 plus sine 1, okay, because it's given that an is so an is this thing when my number n is odd, and an is basically this thing if my n is even. Okay, so I have two different expression for n. One is when n is even, and another one is when n is odd. So for then a2 will become 20. So I just need to substitute 2 in this expression. Okay, 20 minus 1 plus cos 2 by 2. So this is my sequence A2. Or similarly, you can get A3, A4, A5 as well. Okay, so what I want to do here, I want to find the limit of this sequence A. Okay, so again, like so any idea how I should solve this question?
Is the answer is 1?
No. Answer I guess is something else.
Sorry,
But can you
sorry,
tell
sorry,
me
sorry.
why you think this is
It's,
1?
is it 20? Maybe
Even
so. Okay,
not 20 as well.
so what I did, I just divided n from
Hmm?
each term in
Hmm?
odd case and even case. So we have 10 plus 1 upon n plus sin n upon n.
Hmm?
Likewise, we can go ahead
So this
and
is basically sine n
sin n upon n.
n.
And this, yes. And the same thing will be applicable to the even case.
Yeah. So n.
This will be, I think, 11. I'm not sure. Yeah.
If n is
Even.
even, right? So basically what you need to find, you need to find where this both the terms are going when n is going towards
Infinity.
infinity. That is what you want to
Mm.
find. So when n is going towards infinity, then this thing is certainly is going towards 0, right? 1 by n.
Yes. Right, right.
This, it doesn't matter whether n is odd or when n is even. So in both the cases, this will go towards 0, correct? So
Mm.
and here you have a constant thing, right? 10.
Yeah.
So if n is going towards infinity, then certainly this will go towards 10 because this is constant, right? Doesn't matter where this n is going. So the only problematic part is this one, right? Sin n
Mm.
and cos n, right? So we just need to find where this both the things are going when n is going towards plus infinity. So one thing we have you have to notice that the sine function sine x.
Is it 1? Sin n upon n for n tends to
No,
infinity is
no,
equals to
no, no. This is actually 0. So sine x is always what? Less than or equal to 1, right?
1. Right.
Cos x is also less than or equal to 1, right?
Mm.
So what now I can do? So I can divide. So instead of x, I can write n, right? This is n. This is n. So what I can do now? I can divide n over here, right? Correct or no? I can
Mm.
divide that, right? So So, and this thing is greater than equal to 0, right? And this thing is also greater than equal to 0. So I have two things here. So is there any doubt till now?
Only absolute value, right?
Yeah, so this is positive, right? This is positive, okay? And okay, like if you don't want to take the absolute value, doesn't matter. Okay, so instead of that, what you need to take?
-1, yeah, -1 on both sides. Yeah.
Okay, so when n is going towards infinity, then this will go towards 0, correct? And this thing also will go towards 0, right? That means this middle term also will go towards 0, right? So that means this limit of this sine n by n is precisely 0, okay? And similarly, you can find that the limit of this thing cos n by n is also 0. Clear?
Uh,
Yeah. So when n is going towards infinity, then this limit of this part is 0, and limit of this part is also 0.
0.
So now can you tell me the final answer? What will be the limit of this sequence?
11.
10.
20.
11. Sorry,
Why
it'll be
this?
10. 10, 10, 10.
10,
10.
right? So,
Yeah.
so this part is going towards 0, right? And this part is going towards 0. Then you have only this part, right? So this part will go towards 10. So finally, if you add all these things, so the whole thing will go towards 10, right?
Yes.
So is it not like there are two, for example, there is a series of some odd numbers and some even numbers, and we are just calculating from here. The final value of odd terms will be 10 and okay, limit, right? Okay, fine.
We have
Yes,
limit, right?
yes,
Yeah.
yes, yes.
So clear, right? Why this limit of the sequence is 10. Any doubt from this question? Question number 2?
No.
Okay, fine.
I think we got confused with limit of n tending to 0. That time sine of n by n is equal to 1. But when it comes to infinity, it's different. So I think that's where we were all getting confused.
No. So the thing is, you are actually mixing two things. So limit of a sequence is different from limit of a function. Okay, so now you have a sequence. Okay, so when you are talking about limit of a sequence, okay, in that case, you should take this n towards infinity, right? So, but limit of a function, you can actually talk about any particular point. So at that case, x can be anything. But when you are talking about limit of a sequence, you have to take this n towards infinity. You don't have any other possible choice, because by definition, to find the limit of a sequence n, you have to take this n towards plus infinity. Okay, that is how we define the limit of a sequence.
Okay.
Is it? Yeah.
Yes.
Okay, so now let's go to this how we should get the limit of a function. Okay, so as you can see here, here you can see I have a function, and if you see the options here, actually we have asked you to find the limit of this function at some point x equal to 2. Okay, so limit of a function I can talk about at any point which is in the domain of the function. Okay, or in some case I can go outside of the domain as well, but for so now you stick to the domain, you always stick to the points which are inside the domain of the function. Okay, so but here, as you can see, this is completely different. This is a sequence. This all these things, they are defined only for natural numbers. Okay, if you put a natural number, then only you will get some answer. Okay, so similarly here as well. Okay, these are defined. So as I said in the very beginning itself, sequence is a function from natural number to real number. So this is, as you can see here, this function is defined on R. So this is a map some set of real to R. Okay. So what we want to do, we want to find the limit of this function. Okay. So can you tell me how I should find the limit of this function at x equal to 2? Any idea? I want to find the limit.
Yeah, so for what you do is basically you look at the left hand limit, the right hand limit, and the value of the function at x equal to 2.
So we don't have to go to the value of the function at x equal to 2. So that we need to find when we are checking the continuity of this function. Okay. So when actually we're checking the limit of a function. So what basically we need to do? We need to check the left hand limit and the right hand limit. If both the things matches, then we say that the limit of this function at that point exists.
Yeah.
So first thing what we need to do, we need to find the left hand limit. Okay. So can you tell me how what should be the left hand limit of this function at x equal to 2?
Yes. So you can write limit of x tending to 2 negative of x. So that gives you 2. Limit of x tending to 2 negative, 2 negative x.
F of x, right?
F of x equal to.
So that means, so when I'm writing this x tends to minus 2, that means x is always less than or equal to 2, right? That is how that, so that is the reason we write x tends to 2 minus, right? Because we are actually approaching to 2 from its left hand side. So this is my 2 and we are coming to this 2 from the left of this 2, right? So when I'm coming to 2 from its left side, that means I'm coming through the points which are less than or equal to 2, right? So when x is less than or equal to 2, my f of x is what? That is x, right? So in that case, what I can write now? So I can replace this f of x with 2, right?
Correct.
Correct. So then you can easily check that this is precisely 2, right? So this is the left hand limit, right? So the left hand limit of this function at x equal to 2 is 2. So the next thing what I need to find, I need to find the
right hand limit. Yeah.
right hand limit.
Yeah. So you write limit of x tending to 2 positive f of x. So that is equal to 5.
Yes. So again, when I'm writing this x tends to 2 positive, that means I'm coming to this point 2 from its right. That means I'm approaching to 2 by using some points which are greater than or equal to 2. So in that case, this value of this function is precisely 5.
5, yeah.
Which is 5. So that means what will be the final limit, right hand limit?
Equal to 5.
5, right? So now I have two limits, right? So I have left hand limit as well as right hand limit, and certainly they are different, right?
Yeah.
So right hand limit is not equal to left hand limit. So that means I can say that the limit of this function at x equal to 2 doesn't exist. So can I say anything about the continuity of this function at x equal to 2?
Yes, it is discontinuous.
Because certainly the limit, since the limit doesn't exist, from there itself I can say that this function is not continuous at x equal to 2, right?
Yes.
Okay, any doubt from this part?
Maybe my concepts are wrong. I have this question, like if I were to plot f of x, so it will be a line 45 degrees to the axis, and it will cut through 0, 0, and it will go up to 2, and after that it will be a line parallel to x-axis at 5, right?
Yeah, let me
So
draw the graph.
yes. In case it's irrelevant, you can skip this question, but I was just thinking.
No, like by just actually by looking at the graph also you can find the left hand limit and right hand limit as well. So as you can see, f of x is what? Is
X, if x is less than 2,
if
less
x
than or
is
equal to 2.
2. So basically this is your 2. Okay.
Yeah.
So if x is less than 2, then your graph will look like this.
Right.
Okay,
We
so
pass through the axis.
yeah, it should pass the origin.
Right.
So you have this straight line. Okay.
Right.
And if
Right.
x is greater than 2, then it's precisely 5. So then it should look like, so afterwards, it should be a line which is parallel to this x-axis. Okay, so this is your
So
point.
is this the reason why you are saying it's discontinuous?
So you can see, right, is clearly you can see there is a discontinuous continuity in the graph as well, right?
Okay.
So this is 2 at x at 2, this is 2, and afterwards actually it's this graph starts with 5, right?
Hmm.
So clearly there is a discontinuity in this graph itself, right? So from the graph itself, I can say that my function is not continuous at x
Now,
equal to 2.
right. I'm just extrapolating that. So when we see a constant as one of the options,
Hmm.
and the other one is dependent on x,
Hmm.
then it will be discontinuous, right?
Not exactly. Like so for example, if I redefine this function like this, okay,
Hmm.
so instead of 5, if I write it like this.
Oh, okay.
Okay. So instead of 5, if I write this as 2, then this function
Yes.
will be a continuous function, right? Because
Right.
this graph will be something different, right? So
Okay.
then you have a graph like this, right?
Right. Yeah. It ends at 2 and goes like.
Yeah. So this function is certainly it's continuous at x equal to 2. Okay.
Okay.
But
So
again,
Ashish, just a small doubt. For example, we have a sine wave. So our sine wave has a limit of 1 always, but it is a continuous in nature. That means it is changing its value from 0 to 1 and then coming back to 0, then minus, and then back to 0, right? So as we are seeing here also that the values are just changing from x to at last 5, so we are not finding any left hand limit equals to right hand limit. So my question is that if there is a sine wave, then how we are going to calculate this left hand and right hand limit?
sin x is certainly it's a continuous function, like so in that case, so so it's probably the simplest. Okay, so this is sin x is slightly different from this function. So sin x is a periodic function. So this function is certainly not periodic. Okay, so you have something like this, right?
Hmm.
Okay, let me try it out here. This passes through origin. Okay, so you have something like this. Okay, so clearly this sin x, let's say this is your sin x. This is certainly it's different from this function, right? So this is certainly not period. This is a periodic function, right? So similarly, like you can it's depend. Like suppose you want to find the limit extends to 0 sin x, right? So as you can see, first what you need to do, you need to find the left hand limit, right? So when you are coming to 0 from the left hand side, right? So when you are coming to 0 from the left hand side, so where this value of the function is approaching,
0.
this value of the function is also approaching towards 0,
Okay.
right?
And the same thing is also from the right hand side. That's
From
why
the
it
right
is
hand side.
0.
So you can see, so as you can see, there is nothing special about 0, right? There is nothing special about 0. You pick any point, you pick this point, right?
Right.
You pick this point A. So when you are coming to this point A from the right, then as you can see, the value of the function is approaching to this point, right? Let's say this. And when you are coming to A from the left hand side, the value of the function is approaching to this. So for all the points in the domain of this sin x, the left hand limit and right hand limit, they are same, right?
And this will be depending on the amplitude of this sine wave, not the frequency part. Or the means if there is like 2 sine x, then the maximum value will be -2 or +2.
Yeah. So but again, that certainly it's not going to change the continuity of the new function. It
Understood.
certainly it may increase the height, right? So
Right. Yeah,
yeah.
thanks. Understood.
Any other doubt from this part?
No.
Okay, fine. Let's okay. Let me move to the next part. Okay, so the next question is again like so basically to check the
So Bashish, sorry, just the answer for the previous question is option number 3, right?
Yeah, let me check. So the left hand limit is 2, right?
Yeah.
So left hand limit exists at x equal to 2. So that means option 1 is correct, right?
No, it's not. It's not because we have above
Okay,
4
okay.
to
So
5. Yeah.
sorry.
Ah.
Yeah, correct. Limit doesn't exist. Correct. I thought it's written left hand limit exists. Okay. So right limit exists at x equal to 2. So option 2 is correct.
Right limit exist at option.
That
Right.
means this right hand limit.
Okay.
Okay.
Yes.
So we are getting a finite value for this right hand limit, right?
Right.
That means our right limit exists at x equal to 2. So option 2 is correct. Okay. Then left limit at x equal to 2 is 2. That is also correct, right? So if you we have computed the left hand limit of this function, right? So we are getting this left hand limit as 2, right? So that means option 3 is also correct, right? But option 4 is incorrect. It's saying right limit at x equal to 2 is -1. But what we are getting? We are getting 5, right?
Okay.
So option 2 and 3 are correct. Clear?
Yes, sorry.
Okay, fine. Okay, so let's move to the next question. So what we want to do here, we want to check whether this function is continuous at x equal to 0 or not. That is our main problem. So first we need to split the problem. So what we need to first check, can you tell me? So first
Check the left hand limit and right hand limit for x equal to 0.
yeah, at x equal to 0, I need to check the left hand limit and the right hand limit, and then one more thing I need to check. So now I'm not checking whether I'm checking about the continuity of the function. I'm not just checking the limit, whether this limit of this function at x equal to 0 exists or not. I'm going one step forward. I want to check the continuity of the function, right? So I need to check whether both the things are equal and whether they are equal to f of 0 or not. That also I need to check, right, for the continuity.
Yes, correct.
So yeah, so I have to check, I have to find left hand limit, right hand limit, and also I need to check whether both the things are equal to f of 0 or not. Okay, if both the things are equal to f of 0, then only I can say that my function is continuous at x equal to 0. Okay, if both the things are certainly not equal to f of 0, then from there itself I can say that my function is not continuous at x equal to 0. Right. So the first thing is what I need to check. I need to find the left hand limit of this function at x equal to 0, right?
Yes.
Left hand limit at x equal to 0. Okay, so that means x is going towards 0, negative, right? So x is coming to 0 from the left hand side. Okay, so if x is going to 0 from the left hand side, can you tell me where this 1 by x will go?
Negative infinity.
Correct, absolutely correct. So this will go towards minus infinity, right? So once 1 by x is going towards minus infinity, can you tell me where this e power 1 by x will go?
0.
Correct. This will go towards 0. So then 1 plus e power 1 by x will go towards 1, right? So that means this 1 by 1 plus e power 1 by x will go towards 1, right? So that is what we wanted to compute, right? So this is precisely our left hand limit of this function at x equal to 0. So the left hand limit at x equal to 0 is 1, right? Any doubt from this part?
So Vashish, I'm getting the answer as half.
No. Why?
See, suppose you have 1 upon e raised to, suppose you have 1 upon e raised to minus x plus 1. Okay.
No, this is my function, right?
Yeah, 1 upon e raised to minus x plus 1, right?
No. 1 upon
E raised to minus x. E raised to minus x. Yeah,
no,
minus x plus 1.
No, this is different, right? You have 1 by x. You have 1 by x here.
That should be x to the power minus 1.
That should be x power minus 1, not minus x.
Okay.
See this, see what we have here, 1 by x, right? So 1 by x is certainly not equal to minus x, right? So you are basically replacing minus x in place of 1 by x. So minus x is not equal to 1 by x, right? So this is what? This is x inverse.
Okay.
These two things are different. Okay.
Okay.
So yeah, certainly if you take whatever you are doing for this function, okay, this is correct. So if you take this function instead of this function, you will get 2. You will get 2.
Correct. Okay, got it.
So that means my left hand limit of this function at x equal to 0 is 1. Okay, so the next thing what we need to do, I need to find the right hand limit, right? Right hand limit. Okay, so again, to get the right hand limit, what actually we need to do? We need, so by the definition, right hand limit basically means we are coming to 0 from the right hand side of 0, right? That is what so this is the way we find the right hand limit. Okay, so in that case, so when we are coming to 0 from the right hand side of 0, right? So in that case, our x is always positive, right? Or greater than equal to 0. So if we are coming to 0 from the right hand side, then can you tell me where this 1 by x will go?
Plus infinity.
Correct. Plus infinity. So that means where this e power 1 by x will, so this will go towards
infinity.
Absolutely correct. Yeah. So then 1 plus e power 1 by x will go towards plus infinity as well. So if this thing is going towards plus infinity, then the reciprocal of this thing, 1 by 1 plus e power 1 by x will go towards
0.
Okay. So that is what we wanted to find. Okay. So So this 1 is our left hand limit and 0 is our right hand limit. Okay, so as you can see, the left hand limit is not equal to the right hand limit, right?
So Bashir, just go up to the negative. Yeah, go up, scroll up a little more. Yeah, see, it's saying x if x tends to negative infinity, 1 by x tends to minus infinity. E raised to 1 by x will e raised to 1 by x will tend to 0 or tend to minus infinity.
No, see, so e power x is always, it doesn't matter what is the value of e. E power y is always greater than equal to 0, right?
Correct, yeah.
So if you see the graph, this is the graph of e power x, right?
Correct,
So,
yeah.
so e power y is always greater than equal to 0. So then certainly e power 1 by x can't go to minus infinity, right? Because e power x is always greater than equal to 0.
Okay, okay.
That means this, see what we have. We have something, so if you see, this is what? E power minus infinity, right? If I directly replace this minus, I should not write this. So this is
Correct.
mathematically, this is not correct, this expression. So this is more or less, this is 1 by e power infinity, right?
Yeah, correct.
So this is infinite. So then I should get 0.
Correct. Okay, got it.
So yeah, so in both the cases, as you can see, so for this function, my left hand limit and right hand limit, they are different, right? So they don't match. Okay, so that means this function is not continuous at x equal to,
Yeah, Subhashish, can you go just down to the right hand limit?
yes.
Yeah, okay, fine.
Clear, right? This right hand limit part is clear. Okay. Any doubt from this question? Question number 4. Okay. Okay, then I'll move to the next question. Okay, so again, like in this question, you have a bunch of statement. What we need to do. So this statement is more or less related to the differentiability of a function. So you need to find all the correct statements. Okay. So any idea about the statement number 1? Whether the statement number 1 is correct or incorrect?
Yeah, just give us a couple of minutes. I'll just
Yeah.
I don't think so. I think first number is wrong.
Yeah. Can you tell me why?
Because differentiation derivative of cosine function is always a negative. But
Correct.
here we are seeing positive number.
Yeah, we are correct. So can you tell me how I should how I should get the derivative of this function?
So first of all, we can just think this is a sine x. So the derivative of this will be cosine of 2 cos 3x.
Yeah. So basically,
And
what
then
we are doing actually, yeah. So you are actually you are taking the derivative of a composite function, right? So for that, you need to apply the chain rule, right? That is what you are doing. Yeah. Whatever you said is correct. So you need to apply the chain rule. So in this case, you have sine of some f of x, right? So what you need to do, you need to first differentiate this sign. So you will get cos of f of x times, you need to take the derivative of a, right? So first what you need to do, you need to take the derivative of this sign. So once you take the derivative of this sign, what you will get? You will get cos of 2 cos 3x, right?
Hmm.
So next, what you need to do? You need to differentiate this part as well, right? This part. So if you differentiate this bracket part, then what you will get?
-2 sine 3x.
Correct. Minus 2 times 3 times
3 diagrams. Yeah.
sine 3x, right?
Yeah.
Again, actually, again, we are doing the same thing. Again, we are basically we are applying this chain rule to this cos 3 as well. That's why this 3 is coming.
Hmm.
So the total derivative is this cos of 2 cos 3x times minus 6 sine 3x. Okay, so basically, as you can see, you have a minus sign missing here, right? Hello.
Right.
Yeah. So so that's why this option number 1 is incorrect. Okay. So this is an incorrect statement. Is there any doubt from this option number 1? Okay. So what about option number 2?
First, we'll have to find the integral of h.
No.
Because
You
it is
don't-
a derivative.
You don't
It is
have
a derivative.
to. You don't have to actually say everything is given here, right? So the only thing you need to know, you need to know the meaning of this expression.
Is a derivative of the function. Okay,
Yeah.
so it's already h. Fine, got it.
Mhm.
Uh,
Yeah. Yeah. So any idea about this option?
So what they're asking is what they're basically saying is x square plus sine pi x plus e raised to x is actually not equal to 4 plus e square.
No, you need to check whether this thing, whatever it is, this expression,
Yeah.
you need to check whether this thing is equals to this 4 plus e square or not.
Okay.
That is what you need to check.
Is it a wrong statement?
No, if it is wrong, then yeah, you should tell me why it is wrong.
Actually, I have not calculated it, but I was just thinking that if hx is having e to the power x and its sign is positive, and in the
It
next
is the
term,
right it is the right sentence.
I think what they're asking for is a value of h of
It
2.
is
The value of h of 2, and that is indeed
yeah,
equal to 4 plus e square.
yes. It is right sentence.
Yeah. So this is actually
If you are
correct.
putting the value of x is equal to 2, then x square is equal to 4 plus sine 2 pi. Sine 2 pi is 0 and plus e raised to 2. So it is 4 plus e raised to 2.
So
Right?
yeah, correct. Whatever you are saying is
Because you are defining definition of limit x plus h. So here we are taking h is equal to 2. X is
yeah.
equal to 2.
So as I said, like you need to. So one thing you need to know the meaning of this expression, right? So if you see this. What is this thing? So what is this thing? This is what? This is what?
Definition of derivative.
Correct. So this is the derivative of this function f at 2, right? Correct or not? So
Yes,
in the question, it's already given that h of x is the derivative of this function f, right? So that means this should be h of 2, right? Correct? Because I know, basically I know f dash of x is nothing but h. That I know because it's already given in the question. And this f dash 2 is nothing but it's precisely equals to h of 2. So to get the value of this thing, I just need to compute what is h of 2. What is h of 2? This is 4 plus,
E square.
right?
Right. Yes.
As a sine 2 pi is 0.
Yeah, sine 2 pi is 0. So in the end, we'll get 4 plus e square. So that means this statement is correct. So is it clear why this statement 2 is correct?
Yes.
Yeah.
Yes.
So what about option number 3? Any idea?
So for we need, if it's differentiable only if it is continuous. So we need to check for continuity.
No, continuity implies differentiability.
Okay. So okay. So if
Sorry.
it is
Okay, I said it wrong. Differentiability implies continuity. Continuity doesn't imply differentiability. So if it is differentiable, then certainly you can say that this function is continuous. But if this function is continuous, from there you can't say anything about the differentiability of the function.
so like for as x tends to 0, it becomes infinity by infinity form. So it's actually not differentiable.
Why from x tends to 0?
No, x tends to infinity. X
But-
by e raised to x comes to infinity by infinity form. So it's actually not differentiable.
Why you want to check whether this function is differentiable at infinity or not? Because I want to check whether this function is differentiable on R or not, right? That is what I need to check, right? So so do you think infinity is an element of this R? Infinity is not a real number, right? I have said this in the very beginning. It's not a number. So I don't have to check whether this function is differentiable on R on infinity or not. I just need to check whether this function is differentiable on this set of real number, or that is what I need to check. So what, as you can see you have two things here, right? You have something in the numerator and you have something in the denominator, right? So first think about this function. Let's say g of x is equal to x. So whether this function g is differentiable?
Yes.
Yes.
This is a polynomial function, right? So this is always differentiable. So g is differentiable, right? So now you consider this one more function, h of x. So what about h of x, whether h of x is differentiable?
Yes, it's differentiable.
Because that's, if you see, like from the graph, it's pretty clear, like this function is differentiable. Here, if you see the graph of e of x, then as you can see, there is no corner points. You don't have a points something like this, right? So when you have a point, when you have a corner point like this, in that case, you can say that this function is not differentiable. But here you can see this the graph of this function is smooth. It's pretty smooth. So in that, so by just looking at the graph, you can say that this function is also differentiable, right? And one more thing, you know that e of x is not equal to 0 for any x in R,
Yes.
right? Correct or not? So ex can't be 0 because it's always strictly greater than 0. So now you are basically in this form, g of x by h of x. G of x is always differentiable, h of x is always differentiable, and h of x is not equal to 0, right? So you know one of the rule of the differentiability, right? When you have in this case, then this quotient is also what? Differentiable, correct?
Okay.
So that is what actually we are applying here. Here g of x is differentiable, h of x is differentiable. Okay. And one more thing, like I can talk about this h of x because this h I can divide by this h of x because my h of x is always non-zero. Okay. So so now by knowing that g of x and h of x are differentiable, I can say that g of x by h of x is also differentiable. So in particular, my function f of x is also differentiable. Okay. Any doubt?
I was just trying to apply this formula that u by v is equal to v du by dx minus u dv by dx upon v square. So that will not be useful in this case, is it?
No, that actually will give you the derivative of this function. Okay. So to get the derivative of this function, first you need to know whether this function is differentiable or not. Okay, if you don't know this function is differentiable, then how you can take the derivative? Okay, so in the question is actually asking the previous step. Okay, it's asking whether this function is differentiable or not. Okay, so if someone will ask you like what is the derivative of this function, so now you know that this function is differentiable. So if someone will ask the next step, that what will be the derivative of this function, in that case actually you can apply that u by v rule. Okay, so that in that case you can take the derivative plus u by v.
Okay. Got it.
Okay, so what about the next option?
It's similar to what you just explained. So if both are differentiable, then the combination is differentiable.
No, this is a specific example. Like, so here, uh, if I take if I take x and 1 by x, then this is differentiable and this is also differentiable. Then like then you can say that the product is differentiable. Okay, and here also you can say that if so the product, okay, x by e or x is differentiable, from there you can say that x is differential, e power x is differential. So this is true for this, only for this function. Okay, but in option 4 it's asking about a general statement. Okay, so if you are saying this option 4 is correct, then it should hold for all the possible cases, not for a single case. Okay.
So if you had to say f of x is equal to x and g of x is 1 by x squared, then it would not be differentiable.
No, my question is, can you tell me what actually this option number 4 is saying? Okay, what actually you need, it is basically saying?
That if they're both individually differentiable,
No.
then the combination is differentiable.
No. So basically it's saying you have two functions, right? So it's saying f times g, this product is differentiable, right? It's saying if this product is differentiable, okay, then both f and g are differentiable. Okay, so it's saying if the product of two function is differentiable, then both f and g are also differentiable. So do you think this is a correct statement? If yes, then why?
No, because suppose if you had to say, suppose the product of f and g is x, for example, okay, and f is equal to x square and g is 1 by x, for example, then f is differentiable, but g is not differentiable.
G is not differentiable where?
So suppose f multiplied by g is x. There's a combination is differentiable. But individually, if you see, f is x square and g is 1 by x.
1 by x. Yeah.
So where f is differentiable, but g is not differentiable.
So where this g is not differentiable?
Because there is a value. So the reason why it's not differentiable is because when it tends to 0, like 0 is an asymptote, na? So that results in a discontinuity at x equal to 0.
So the thing is, okay, so the problem is, see, so there is a difference. See, 0 is not in the domain of G, right? 0 is not in the domain of G.
Correct.
So if it is not in the domain of G, then certainly I can't talk about the differentiability of this function at x equal to 0. See, I can talk about continuity and differentiability of a function at a point if that point is inside the domain of the function. Okay. So 0 is not in the domain of the function, right? So in that case, I can talk about the differentiability of G at 0, because at 0, my G is not defined. Okay. So whatever you are saying is correct. Like this statement is certainly not correct. It's not correct, but you need to give a example actually through which you can disprove this. This is not a correct example.
Okay.
So for example, actually, you need to modify
Subhashish,
this. Yes.
can we think the same thing like that? If f is something x and g is equal to uh, like 1 upon 0, or we can say infinity.
So infinity is again, like you have to take real functions, right?
Okay,
So
real functions.
when you are taking infinity is not a real number. It's something different, and you have to define some new rules to talk about differentiability at infinity probably.
Yeah, actually, I was just thinking about any example that is not differentiable.
Yeah. So and yes, and also you have to show that the product of these two function is differentiable. Okay. See, if I take, let's say, mod x, okay, times mod x, right? If I take mod x, so my f and g are same, right? F and g are same. So f is mod x, gx is mod x. Whether this f is differentiable?
No.
Mod,
Because
so if you draw the graph of mod x,
it's not differentiable.
Differentiable, right? So what is the product of f? What is f times g?
X square.
This is x square, right?
Ah.
X square is differentiable, right?
Yes.
This is a polynomial,
Yes.
right?
Yes.
But both f and g are
not differentiable. Okay.
not differentiable. So that's why this statement, whatever statement it is, this is a incorrect statement. Clear?
Yeah.
Yeah. So then basically you have two correct statements. Okay, so this is correct statement, this is correct statement. Okay. So yeah. So the next thing is something related to differentiability as well as tangent. Okay, so what this question is saying, suppose you have a differentiable function, okay, and f is a differentiable function, and the derivative of this function at 3 is 2, right? The derivative of this function at 3 is 2, and the value of the function at 3 is -7. Okay, and it is saying that suppose you have a line y, okay, which is ax plus b. This line is nothing but is the tangent line of the function at x equal to 3. So if this line denotes the tangent of the function at x equal to 3, then you need to find the value of a plus b. So any idea?
Yeah, so what they're basically saying when they're saying y equal to ax plus b is basically f dash, right? So
No, f dash is what? F dash is a number, right? Or
yeah, so they're giving you f dash of
You
x
can
is
take
basically
the value. Value of b is 2.
why value of b is 2?
You have taken the derivative of y is equal to ax plus b, where y is a f of function. So if you are taking the derivative of
Hello, you're not audible, Anu.
function, then f of 3 is equal
F dash of 3 is 2, right? And one more thing is given that f of 3 is 7, right? So what is this line? This line basically it's the tangent line of this function at x equal to 3, right? This line is nothing but the tangent line of this function at x equal to 3. You see, so anyone wants to try this question? Like, any idea how?
yeah, I'd like to try it. So basically it's saying that the tangent of the function is given by ax plus b. Okay, so if f of x is a function, then f dash of x is equal to ax plus b.
No, so not ax plus b. F dash is the derivative of the function. Okay, so this
Correct.
is a
So,
line. Yeah.
so the derivative is given by the tangent at that point, right?
Derivative will give you the slope of the tangent, not the
hello.
tangent.
So value of a is 2.
Value of a is 2. Yeah, correct. Now you're saying whatever value of a is
2, because if you are taking the derivative of y is equal to x plus b, so b gets constant, so its derivative is 0. So x is a and f of f dash of 3 is 2, so a is 2,
correct. So
right?
suppose,
And putting that value in your original signal, you will get the value of b.
yes, correct. So okay, so let me. So suppose this is my f. This is the graph of f. Okay, and this is 3. Okay, and this point, as I know, the value of the function at 3 is nothing but -7. Okay, so this is 3 minus 7, right? So this derivative of this function at 3, that is f dash 3, will give me the slope of this line. Okay, so suppose this line L, so this line is precisely ax plus b. So f dash of 3 will give me slope of this line. Slope of this line y equal to ax plus b, right? So the slope of this line is what? What is the slope of this line?
A.
It's 2.
2, yeah.
2.
Yeah.
2, right? And also you know that this line passes through 3 minus 7, correct? You know that you know the slope of the line, and also you know that the line passes through 3 comma minus 7. So now can you tell me what will be the equation of this line?
point form.
Sorry?
He means the slope point form.
Yeah, so can you tell me the final answer? Hello? Hello?
-11.
Minus
No,
13. Minus 13.
yeah, basically I'm asking the
Sir, if slope is equal to
are you
2
able to
and
see the question now?
Sir, am I audible?
No, are you able to see the question now? Hello?
Am I audible?
Yeah, you are audible, but my question is, are you able to see the question now?
Yes.
Yes. So
Yes.
if slope is equal to 2, then if we substitute in y is equal to mx plus c, then m is equal to 2. And we compare, then a is equal to 2. Is that
Yeah.
what you're asking?
Yeah, a equal to 2. Actually, I'm not asking about a equal to 2. I'm asking something different. I'm asking what will be the equation of the line. Okay, now
Y
you
equal
know.
to 2x minus 13.
It's
Huh.
equal. It's actually a y plus 7 is equal to 2 into x minus 3.
Yes, probably, yeah. So okay, so this is actually a one-line calculation. So you know the slope of this line, right? You know the slope of this line is 2, right? So then you can write this as 2x plus c, correct? So this is your c is your y-intercept. And one more thing, you know that this line passes through this point, right? Correct?
Yes. Correct.
So then if you put this point in this line should satisfy this point, right? So that means if I substitute -7 here and then 2 times in place of x, if I substitute 3, then this line should satisfy this point. That means my c is what? My c is minus
13.
13, right? That means the equation of this line is 2x minus 13, right? So from here I can say that a is 2 and b is what? Minus
13.
13. So if I add these two things, I will get minus 11, right?
Right.
Okay. Yeah. So yeah. So basically, to get a tangent, actually you need two things. Okay. So in most of the cases, you need the slope of this line. Okay. And you need this point. Okay. If you know one of the points of the tangent and if you know the slope, then you can easily calculate the equation of the tangent. Is it clear now? Question number 6.
Yes.
Yes, it's clear.
Okay, so let's move to the next question. Okay, so yeah, so basically what we need to do here, we need to find the integrals of these two things. Okay, so can you tell me how I should solve the first one, this one?
Since this is an odd function, the total length will be 0.
Correct. So you know, right, if f is odd, that means minus a to a, f of x is 0, right? So for that, what I need to do, I need to check whether this is a odd function or not. Okay, so can you tell me how should I check whether a function is odd or not? What I need to show?
F of minus x should be minus f of x.
Of minus x is precisely f minus of f of x. So here, what is f? So here my f of x is what? X plus sine pi x, right? So if I write f of minus x, it's nothing but minus x plus sine minus pi x, right? And one more thing, we know that sine function is a odd function, so that I can write x minus sine pi x, right? So what in the end, what I am getting here, I am getting minus of f of x. Okay, so this whatever function it is, this is a odd function. Okay, so since this is a odd function, and as you can see, what actually I am doing here, I am taking this definite integral from minus pi to pi. So basically I am taking this minus a to, so you can see the formula minus a to a. Okay, so I can directly apply this tool here, and I can say that the limit integration of this function from minus pi to pi is 0. Clear?
Yes, it's clear.
So what about the next one?
We use integration by parts.
Yes. So okay, let me first write this one. So what is this? 0 to 1 by 2, right? Let me check. 0 to 1 by 2, 8x e power 2x. 8x e power 2x dx, right?
Yeah.
Yeah. So okay. So yeah. So what we need to do?
So let's assign. So the 8 comes out anyways. Then
Yeah.
for x e raised to 2x, you put
So
x as.
so this is precisely 8 times this. Okay. So okay. So we can remove this 8, and we later we can multiply 8 with the final result, right? Okay. So eventually we need to find the uh, definite integral of this function. Yeah, continue. What?
So suppose we assign x as u and e raised to 2x as v. X as u and e raised to 2x as v. So we get the formula for that is u comma v.
Sorry,
u v
v
minus integral of v du by dx.
v
v du du
by
v du by dx. Yeah.
sorry, v du by dx.
Yeah, v du.
So do you think this formula is correct?
I think so, but I don't know. I'm not sure. I think so. I think it's correct.
So okay, so yeah,
There should be some repeating pattern if I
actually, so
v
what
du
actually
dx.
what actually, so whatever you are whatever you are saying, actually, if this is in slightly different form, that probably u times v dash. Okay, so if certainly it's only in this u form, then you need to take u times integration of v, okay, minus, okay, du, okay, du by, so here my function is in terms of x, du by dx
Into u,
integration
into v.
into integration of v. Okay, so whatever c said, actually this I guess you can write for this formula when you have some v dash. Okay, not okay. Yeah. So
Is this second integration will also be there for v again?
which one?
The last integration.
You are saying this
Uh,
one, right?
no, yes, this
Yeah,
integration.
yeah. This has to be there.
Okay.
Okay, so okay, so yeah. So basically, here you can see this. So again, like you have to choose this u and v slightly carefully. So for here, actually, we need to take this u. So here u is precisely x. Okay, and this b is precisely e power 2x. There is one rule, right? This islet. Inverse function, logarithmic function, algebraic function, trigonometric function, and this exponential function. So whoever comes first, that you have to take as your u, right? So as you can see, x is what? X is a algebraic function, right? So that's why this. So if you see this list, so in this place x comes in this place, and here you have e, exponential function. So this e power 2x comes second, right? So that's why we're choosing this x as our u. Okay. So okay, so first find the integral. Okay, so let me take x power 2x. It's nothing but what? It's u, that is x time e power 2x, right? Minus derivative of u, that is dx by dx is nothing but it's 1, right? So this I can write it, it's a 1, and then I need to take the integration of e power 2x dx, right? So what will be this value? X times
e to the power 2x upon 2
e power 2x by
upon 2.
2 minus what we need to take here. This is e power 2x by
2.
2 dx, right? And again we need to integrate it. So this is x e 2x by 2 minus this is what? If I do, then what I'll get? E power
e to the power minus e to the power 2x.
2x by 4, right?
Hmm.
Because if I take this half out and if
Hmm.
I integrate e power 2x, then again I will get e power 2x by 2. So you just need to multiply this 2 in the denominator twice. Okay, so you will get 4, right? So this is your integration of this function, right? So, and we have a 8, we have a 8 here, right? So we have a 8 here. So if I multiply this 8 with whole thing, then what I will get in the end? It's what? 4x e power 2x minus
2 e to the power 2x.
2 e to the power 2x, right? So, okay. So now what we need to do? We need to find the definite integral, right? So we need to find 8x e power 2x 0 to half, right? So for that, what we need to do? We need to take first, so this is 0 to half 4x e power 2x minus 2 times e power 2x, right? So first what we need to do? We need to substitute this half over here. So if I substitute half, then what I will get? What I will get? Can you tell me? This is half 2 e.
2e minus
This is also 2e, right?
2e.
And again, I need to substitute 0. If I substitute 0, this is precisely 0.
Hmm.
And this is 0 minus 2, right? So,
Yes.
so this is 0, 0 minus of minus 2, which is
2.
2, right?
Hmm.
So this part is clear, right? Hello.
Yes.
Yeah. Okay, so yeah, so okay, so these are the question actually I have prepared for this session. So from now onwards, I can take your doubts. If you have any doubts, then I can
A quick
explain.
question. A quick question. Why didn't we take to check whether the function is odd or not here? We use the UV method here,
Okay,
but why didn't we check?
so the thing is, okay, so I know that this function is neither so this function is not odd. Okay, so that's why I didn't check. Okay, so
Okay.
I already know the answer. So for example, if you see this question, so to solve this question, actually I know that first I have to use this method, right?
Okay.
So to solve this question, I have to use this method. Okay, so that's why actually I was initially I was interested to check whether this function is odd and even. Okay, so but I know that in this way I can't solve this question. So
Okay, can we assume something like if there is a x and e power something x is involved, it will not be odd? Is there some shortcuts like that? Maybe you can tell us those.
no, see the thing is e power x is neither odd nor even. Okay, so
Okay.
so when you have see here if you see here you have some sum, right? This x is odd, okay, and this is also odd. Okay, so when you have sum up to odd function, okay, then you will get a odd function. Okay, and when you have product of two odd function, okay, you will get a even function. Okay, so here as you can see x is
1 minute. Usually we say that when we multiply two odd numbers, we get an odd number. When you sum two odd numbers, you get even, right? So this one is little.
no, this is slightly different. Okay, so that
Okay.
number, yeah.
Okay.
So actually here you have odd function. This x is odd. Okay, but the problem here is this e power 2x. So this e power 2x is neither odd nor even. Okay, so when you multiply this x with e power 2x, so mostly you will not get. So the final result will also be again neither odd nor even. So when you have some product of two odd function or even function, then actually you can get some good result. So when you have product of some slightly so as you said, like when you have this exponential function, so most likely you will not get any good result. Okay.
Okay.
Subhashish, I think this odd and even functionalities are defined on minus infinity to infinity, or we can say minus a to a, this type of limits only.
Yeah.
On that basis, we can check that conditions.
Yeah.
Otherwise, we don't need to.
So the thing is, yeah, you are correct in some sense. So one thing actually what you can do, so to apply, so even if you know this, even if you know that this function is odd, okay, and then also you can't do much because as I said, as you have pointed out, so you can apply the result when your integration is basically from minus
Right.
a to a, right? So in the first question, if you see, so your integration is basically from minus pi to pi. Okay.
That's why we are checking that thing.
Yeah.
And in the second question, it is not like that. That's why we are not going to check it.
So in you are correct. So in the first question, so when you have a form like this, and if you know that this function is odd, then actually you can easily compute the integration. Okay. So when you know that when you have this form and you know that this function is odd or maybe even, you can easily, or in even you still have to do a lot of computation, but if it is odd then you can do it quickly. Okay, and for this function, even if you know that this function is odd, still it's not going to help you much because this integration is not from minus a to a. So if I change this integration from minus half to half, okay, then then it will be better in the beginning, if you check whether this function is odd or even.
Yes.
Okay.
That's
Okay.
Can you just
This
quickly
is a
recall?
good shortcut. Yeah.
Yeah.
Can you just quickly recall what output can we get if it is an even function? Something like that, if there is a shortcut for that also.
No, there is not much shortcut. Like, see, if you have a even function, then basically this integration. Okay, so for even function, actually you have to do the integration. So suppose you have a function like this, a to a f of x, and f of x is even. Okay, so then this is nothing but 0 to a 2 times
Yeah.
f of x. So still you have to do the integration. Okay, so
Yes.
not much
Okay.
advantage, but again, like if so you have a 0 here, then in the end probably you have slightly you can do the computation quickly, but again this is not going to help you much. But for the case of odd function, actually you can do it very quickly. It's 0.
Okay. So in the examination, are we allowed to use online screen calculators also?
Yeah, there will be a calculator from in the portal. Okay, you can use that calculator, but you can't
Okay.
take your own calculator.
Yeah. Okay.
And what will be duration for each paper?
I guess so. Duration, well, it's 1 hour, correct? 1 hour or
I think there is no restriction. The total examination is for 4 hours, and one part there are 4 parts, and I think maybe I'm wrong. There is no limit in the, for example, in third hour we can apply first sections also.
okay. So basically you have 3 papers, okay, and for 3 papers you are getting 4 hours, right?
Yeah.
Yeah. Yeah. So as far as I remember, you have maybe some 11 questions or something like that.
That I'm not sure.
At
11
least
questions max only.
yeah, for maths, I can't say anything about I can't say anything about different courses, but for maths,
Okay.
as far as
Yeah,
remember,
that helps. That helps.
okay, maybe
Okay.
11. Okay, I should not tell this thing. Okay, let me check.
So will the
Yes.
questions be combination of MCQ and descriptive?
No, so either you have NAT or MSQ or MCQ.
Okay.
So for some question you just need to write the answer, that numerical value, and some question can have multiple correct
Okay.
option, and some question will have only single correct option. Okay. And for multiple correct questions, okay, if you are if you are submitting only correct answer, okay, only suppose you have 2 correct answer and you are submitting only 1 correct answer, okay, in that case you will get partial mark. Okay.
Oh, okay.
If you submit some wrong, so suppose you have 2 correct answer and you have submitted 1 correct answer along with 1 wrong option. Okay. So in that case you will lose all the marks.
Oh, okay.
So that is the difference between this MCQ and MSQ.
And any negative marking also is also there?
No. There is no
Okay.
negative.
Okay.
Okay, sorry. Yeah, you have 15 questions. You
Okay.
have 15 questions in your paper.
Okay. Thank you.
Is there any other thing you want me to discuss? Some questions or some doubt?
So Vashish, can you go to the question on the mock question which is given for the maths paper in the video section, and go to question number 5. It's a log question.
Mock paper for what?
Wait, I will do one thing. I'll put the link in the chat box. Just a minute. The fifth question.
Yeah, just a minute. Let me open this.
So
Yeah.
what is the value of x? So I'm
Are
getting
you
that there
sharing
is
these? Excuse me. Are you sharing the screen? I'm not able to see.
Just a minute. Let me share it.
Yeah. Thank you.
Yeah. Can you see the screen now?
not yet. Yeah.
Yes. Yes.
Yeah. Question 5. So I want to know how the answer is equal to 1. Like, how do you arrive at an answer equal to 1? How does the value of x come to 1? How do you get that?
Yeah, just a minute. Let me write the question. Then only I can tell you the answer. So what you have two things, right? You have p of x which is m power log 5x square. M power log 5.
Sorry, this is log 5x square, or this is log x square to the base 5?
Log x square base 5. Okay.
Okay.
I think so. Yeah. Log x square base 5. Yeah. And what is q of x? What is q of x? Q of x is x power
X power log m to the base 5.
x power log m base 5, right? So one more thing is given, right?
Yeah. So Bashish, your screen is blank somehow. Yeah, I can see it.
Yeah, got your screen back.
Okay. So actually, I'm checking this question and I'm writing actually on the journal. So I'll once I write this, then I'll go back to the journal in just a minute. So one more thing is given that m is greater than 1. Okay. And p of x times q of x is 1, right? Okay. Just a minute. Let me share this journal now. Right? Now you can see this thing, right?
Yes.
Yeah. So suppose you have a fixed x. Okay. So for a fixed x, and as well as m is greater than 1, this p of x times q of x is 1, right? And once we have this, we need to find the value of x. Correct? Hello?
Yes.
Yeah. So yes. Okay, so just let me, you have x power 5 log n. Yeah, right. So now what you do, you multiply both the things. Okay. So m power log 5 x square times x power log 5 n, right? So this is equals to 1, right? Hello?
Yes, yes.
Yeah, so from now what actually you can conclude? So from here, what you can conclude?
Log on both sides.
Sorry?
I'm just assuming log on both sides.
So you are taking log on both sides. So log what? Log 5, right? You need to take log 5, right?
Mm.
You can
Yes.
take
So
ln also. Ln also.
but
can.
ln, so why you want to take ln? You have bunch of log here. Okay, so why you
Can
want to
we
take?
can we convert this log to e to the power something? Just by, for example, it is log
Okay,
e
so
equals to
but
e to the
okay,
power
I
x upon
certainly
x.
okay, I don't know the answer, but I feel it's better to take log 5 on both sides. So because okay, so this is log 5 m a square times so times x log 5 m, which is log 5 1, right? Correct?
Yes.
So
Yes.
then what I will get here? What is log a times b?
Log a plus log b.
Yeah. Okay.
Log A plus log B.
So now I need to apply this log 5 x square times log 5 m, right? Because basically I have taken this thing, then I have taken this log out. Okay. And one more thing, what I can do, I can take log 5 m times log 5 x, right? Is it clear till now, or have you missed anything?
Yeah. When there's an exponent, you will take it outside.
Yeah. So no, whoever asked this question, are you still with me?
Yes, yes, yes.
Yeah. So, and what is this value? What is this value?
That will be equal to 0.
Yes, correct. So, okay, so this is what? This is 2 log 5 x, right? Times log 5
M to base. Yeah.
and this is basically the same thing, right? So
Right.
this will be what? 3 times 0, right?
Okay, okay.
So now,
I think 3 multiplied log m to base 5 is a constant. So that again, it becomes,
sorry, which one is the constant?
so you have 3 multiplied by log m to base 5 multiplied by log x to base 5, right? So that gives you log x to base 5 equal to 0.
So this is what? This I can remove this 3, right? And one thing is given here that m is greater than 1, right? Correct or not?
Yes,
Hello.
yes, yes.
So
Yes.
if m is greater than 1, okay, this log, so this is non-zero, right?
Yes.
So
Yes.
so that means I can take this out as well, right?
Yeah.
So finally, I'm left with this thing.
Correct.
Okay. So if this is 0, that means what is the possible value of x?
1.
Yeah.
Okay. Thank you so much, Abhishek.
Yeah.
One quick question. On the
Hmm.
previous step,
Hmm.
there was log x squared to the base 5 multiplied by log m to the base 5.
Hmm.
So you took the 2 outside.
Hmm.
And
So
okay,
this
those are 3 terms, 3 times that. Okay, understood.
Yeah, so basically, I have skipped a lot of things. The properties of it. This I can take this out too. So
Yeah.
then it will be 2, and I have the same thing here, right? So
Same
this is basically what 2x plus
2a plus 1a, which is 3a. Yeah.
Yeah, correct.
Yeah.
2a plus 1a. It's better, right?
And 3 times a equals 0, then a will be 0. Then
Yeah.
of the 2 terms, one is positive, so the other term should be 0.
Yes.
And in such a case, 5 power 0 is okay, 1.
Yeah.
Okay.
Yeah.
Thank you.
Yeah. Okay, anything else?
There is a 8th question in the same paper.
Okay.
It's asking what is the most possible representation of a function f of x equal to 1 by 1 plus e power x. Yes, that's the question.
You can see, right? So, yeah.
Basically, I'm not well versed with what each one will look like. So, is there a way we can interpret and find out?
Okay, so certainly again, like I also have to check what will be the.
One thing is when x is equal to 0, what happens?
Yeah. So okay. So 1 by 1 plus e power x, right? Okay. Let me write this question. Then probably we can discuss. In place after. So what is your function? 1 by 1 plus e power x, right?
Right.
So one thing, if x will go towards infinity, if x will go towards infinity, minus infinity, so where this function will go?
0.
No, not 0. See, if x is
1.
e power
X goes to 0.
1.
1.
Yeah. So
X goes to minus infinity, e power x goes to 0.
0, right? So in that case, f of x will go towards 1, right? So as you can see, so from here actually you can say that 1 actually will be asymptote, right? So if you draw this line 1, let's say x equal to 1, okay? So this is x equal to 1. So, and one more thing, actually, you can see that this f of x, okay, this f of x is always less than or equal to 1, right? Correct or not? Is it very much clear to you why this f of x is always
Yes, because e of x is always positive, so the denominator is always greater than 1.
Yeah. So this e of x is always greater than or equal to 0, and 1 plus e of x is always greater than 1. So if you take the reciprocal, that is 1 by 1 plus e of x is always less than or equal to 1. So, and when we are going towards infinity, okay, when we are going towards, minus infinity, the value of the function is going towards 1, right? So the value of the function is going towards 1. It's closer and closer to 1. Okay. And at x equal to 0, what is the value of this function? 2, right?
1 by 2.
1 by
1 by 2.
1 by 2, right? And when x is going towards infinity, where this value of the function will go, it will go towards 0, right?
0.
If x is going towards plus infinity, then e power x will go towards also plus infinity. Then 1 by 1 plus e power x will go towards 0. So then when you are going, x is going towards plus infinity, it will come closer and closer to 0. Right? Come closer and closer to 0. So in your left hand side, this x equal to 1 is asymptote, and in your right hand side, this x axis is your asymptote. So now if you go back and check the options, as you can see, this is the possible option.
Okay.
Right? Is it clear now? Hello?
Yes. When E is minus infinity, can you
Hmm.
explain that one more time? So it
Which
will
one?
become E becomes minus infinity.
Are you talking about this one or this?
Yeah, sorry. X tends to minus infinity.
Hmm.
E power x will be 1 by e power infinity, which will be tending to 0.
Yeah.
Okay.
So if you see, this is okay. Again, I'm not, whatever I'll write, this is not mathematically correct. So you take this x as minus infinity, right? So then what you will get? E power minus infinity, right? This is 1 by e power infinity, right? So in 1 by e power infinity is what? This is infinity, right?
Right.
So then 1 by infinity. So then you should get 0, right?
Right. Got it. Yes. Thank you.
Yeah. Okay. Anything else?
We'll be covering graphs in the next session, sir.
Yes. Graphs will cover in the next session. Okay.
What are the topics?
No, basically some algorithm is there. So some few algorithm, this topological sequence, some shortest path sequence mostly,
Okay.
and some adjacency matrix as well. And there are a lot of things actually.
Okay.
But I guess it's up to the instructor that what he is going to discuss. Okay. So mostly we'll discuss few things that are that are important for your exams. Okay. Mostly we try to cover the concept that are important for your exams.
Okay.
Okay. So then okay. So now I'll stop the session. You don't have any questions.
Okay, Subhashish.
Just give us 1 more minute, Subhashish. Let me just go through the question paper just to see if there's anything else I can ask you.
Okay.
And all this Riemann sum algorithm and all is there for the exam? Okay, so will that be covered in the next class?
Okay, so again, like certainly it's not possible to cover all the concepts. So
Okay.
yeah.
Okay. Just a minute. Can you go to question 7?
Question 7. Okay.
Yeah, I don't need you to solve the SSE part, but can you just simplify y? Only just simplify y.
Okay, so okay, I guess this is so. Just give me a minute. Let me take a photo of this question. So what is this? This y is what? Log some 1001, sorry, 101, 11 power log 101. Oh my God. So this is 101 power x power 5 minus. Okay, I don't know who gave this question. Okay.
There should be some way to minimize this to a smaller.
Yeah, so it's It's certainly it's not difficult, okay, but again, like, but it's a bit odd. So mostly I think whatever this value of x are given here, mostly I can guess that these values are the roots of this polynomials. Okay, whatever polynomial is given. So if I substitute -2 here, then what I will get? Can you tell me? If I substitute -2 here, then what I should get? Hello? Hello?
Yeah.
If I substitute -2, what I will get? Here, only in this equation. -2 power 5, this is precisely 32.
Minus
Then
32
yeah, -32, then 8
plus 40 minus 8, which is 0.
So this is 0 and this is 0. So then this is k and this is 0. If this is 0, then what you will get? Log 101 power 0, this is 1. Okay, so then this thing is 1. And again, if you take this log 0 1 0 1 power this is 1, then again this is 0. So finally what you will get? Log 101 11 power 0, which is 1, and again what you will get? This is 0. So finally for x equal to -2, this value is basically k. Okay, and you can try again, like see, we'll certainly will not ask this type of question in exam. Okay.
Subhashish, just one more thing is now the questions that you are solving with us, generally the level of the exam is more difficult than what you're teaching or easier, or it's the same level? How does it?
Okay, so the thing is, some of the questions are more or less, not some, most of the questions are more or less of the same level. Okay.
Okay.
And some of the questions are slightly difficult level.
Sure.
But most likely you won't get questions which are easier than the level of the question that I have discussed. Okay.
Okay.
But one thing I can assure you that at least 60% of the question will be of the same level, that whatever I discussed.
Okay. Okay. All right.
And very silly question: do we get lots of rough paper there?
Yeah. The rough paper,
Okay.
you will get unlimited rough paper, but as much as you. Yeah. Okay.
Thank you, Subhashish. The questions
Yeah.
were really nice. Thank you. We learned a
Yeah,
lot from
thanks.
the lecture. Thank you so
Thanks.
much.
Thanks.
Thank you. All right, bye everybody. All the best.
Yeah.
All the best.
Okay.
Thanks.
Okay.
Subash.
Okay. Yeah. Okay. Bye, and all the best to you.
Thanks. Bye.
Thanks.